So to start off with, we're going to define a new angular measure. So instead of degrees, radians actually turns out to be a more efficient measure for angles, certainly when we combine the idea with calculus. So let's look at how we convert. Now, the way I remember it is this. 360 degrees is 2 pi radians. So it's basically pi is 180 degrees. But I remember it this way because, of course, a complete circle is 360 degrees. And I know the circumference of a circle is 2 pi r. So I can associate 2 pi with 360 quite easily. So that's what I use. 360 degrees is 2 pi radians. Now, what we're going to see is a lot of common angles, just like we did in degrees. So let's have a look at these common ones. The ones we will see turn up a lot. So in our first quadrant, 30 degrees, well, that will be pi on 6. 45 degrees, pi on 4. 60 degrees, pi on 3. Now, with the 30 and the 60, it's so easy to get them the wrong way around, because 30 is pi on 6, 60 is pi on 3. Don't confuse those two. And then the boundary value of 90 degrees would be pi on 2. We then move in the second quadrant, and in the second quadrant, we'll see ones like 120, 2 pi on 3, 135, 3 pi on 4, 150, 5 pi on 6, 180 is, of course, pi. Then we move to the third quadrant. And in the third quadrant, our common ones, 210, 7 pi on 6, 225, 5 pi on 4, 240, 4 pi on 3, 270, 3 pi on 2, and finally our fourth quadrant, 300, 5 pi on 3, 315, 7 pi on 4, 330, 11 pi on 6, and we get all the way around the circle. 360 is 2 pi. Now, I'm not saying memorize all these. All I'm saying is these are ones that will come up a lot. You'll see these values quite often. And after a while, you will just memorize them because you've seen them so many times. What happens if it's something else, though? So say it was 67 degrees, and we want to put that in radians. Well, we multiply by pi on 180. That's to do with that conversion. Pi radians is 180 degrees, or 2 pi is 360, whichever way you want to remember it. But we multiply by pi on 180. Now, pi is 3.14, etc., etc., etc. Whatever 67 times 3.14, etc., 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 divided by 180, that's how many radians you have, which when you calculate it out will be 1.1693 to 4 decimal places. 36 degrees, well, 36 pi on 180, again, multiplied by pi on 180, that simplifies down, it's pi on 5 radians. What if you want to go the other way? So we've got pi on 8 radians. Well, now we multiply by the reciprocal. We'll multiply by 180 on pi. The pi's cancel. We end up with 22.5 degrees in this case. You don't have to have pi in it. Remember, pi is just an irrational number. So 111.1 radians, again, multiply by 180 divided by pi, and we end up with quite a lot of degrees. 6,365.6 degrees. Because the thing is, 1 radian is so much bigger than 1 degree. Okay, so 11G is just playing with the conversions, some of those common questions we saw before, but using radians instead of degrees. So getting familiar with radians.